Hello and welcome to PMCD MATHS Teaching. This session we're looking at loci, the introduction to loci, which I will start with perpendicular and angle bisector, which I think most people do, so there's no surprise there. My name is Paul McDonough. This is primarily, as I said, aimed at new teachers or teachers to maths anyway, but experienced teachers may pick up something that they would like to use in their lessons as well, so keep watching. Okay, as usual, what I'll do is I'll give you a rationale for my approach here, or reasons for the way that I approach this. So that second paragraph, I was saying about those questions, this is something I do on a regular basis. I think if you're a new teacher, I think it's a good habit to get in practice with. Get practice getting that habit, because if you're doing that, you're always going to be looking at ways of making your lessons more interesting. Now, there's a warning, you can't do this every single lesson. You just won't have the time when you have a full timetable. But if you sort of commit to a couple of times a month, let's see how I spell it. A couple of times a month, then bit by bit over the years, months, you'll build up a bank of lessons. I've been teaching over 20 years. I haven't got every lesson like this, but I've got enough lessons now that they crop up quite often, and it just keeps the momentum and interest of learning maths going. And again, like I said, not every student is going to be into it, but if you can get the vast majority, then you're winning the battle, aren't you? And it's an enjoyable experience for all of you then. Practical. What tends to have you look ahead, you're planning, and it creeps up with you before you know it, and then you can just end up resorting to the textbook because I haven't got time to get my copying in. I get my copying done if I want to do this, or I just haven't got time to design this. So thinking ahead is really important with anything that's practical in maths. If you don't want to resort to just a sequence of instructions and then pupils just repeating it, in their exercise book. So, and the other thing I want to mention is the word magical. I think I've mentioned it before in things that I've done. When I learned maths, some of the rules that appeared for some of the topics, I think I mentioned solving linear equations when 3x plus 5 equals 19, and then plus 5 moves over and magically it turns into -5. Well, that magic in maths, it's not magic, is it? I say it's not magic, it's magical. Okay, we go for that angle on it. Okay, so hopefully they're going to enjoy this. So I'll start off with sequence of teaching. So starting here, constructing perpendicular angle bisectors. Those two below, they can be done either way around. Now, what I'm talking about with constructions there is not using all the constructions. If you think back, those perhaps people who remember this, to SATs type questions, and you can look these up again. There's plenty of websites that have old SATs paper questions which have loci problems in them, because obviously some of you may know you've even seen these before. And then look at the GCSE and what sort of questions come in there, and then you can make your own up actually and think about practically what problems you can have there. But I'm going to do another video on that one. And finally, constructing all loci. That's all the ones you'll need for GCSE. And things like constructing a perpendicular from a point to a line, having 2 points and constructing a perpendicular bisector between those 2 points on the line as well. Okay, so that's what I'd suggest with that, and let's get into what I'll start off with the lesson. So the first thing I do is, as they come in, this would be the activity that I'd get them to do. So it's a very quick thing. And I'll mention this time that Leonardo da Vinci, there is a myth surrounding Leonardo da Vinci that he was able to draw a freehand circle perfectly. So we're trying to see how good that. It's a good thing for you to do in the class as well. Although I've drawn that on the screen there, you can do your own. You could do it live with them. So they can see how amazing you are at drawing circles, and it is amazing how much better you get. I'll say, so you can see how bad my words start off with if you think that's better, but how better you get over the years of drawing circles when you've been doing it for a long time. So then we have a little talk about loci. being the plural of locus, and the definition. Again, definitions I think are important so they understand it. So loci, they've already come across loci if they plotted any graph really, because the y and x coordinate follow a rule. It's a set of points that follow some rule, and joining them up gives us a loci. But again, interest, trying to get their interest here. Crop circles. I mean, you could do a whole lesson around that if you wanted to. Just these are just suggestions I'm making here. It's not hard and fast that this is the only way to do it. Okay, so we start off with, we do have to do a bit of the step-by-step being able to do this. So what I do with this one here is I'll get them, again, I'll get them to follow a set of instructions, which, for pupils in secondary school, that can be hard to do, just following those instructions. And I'll try not to give too much verbal support for this and just keep referring them to the board. Okay. So this draw all the points 5 centimetres for point P. What does that mean? Let's see them getting the ruler out, but without actually telling them what to do. I don't get the compass out at this stage. They have to think. I'm trying to make them do as much thinking as possible. If you say, "Oh, draw a circle," that might be a discussion point. If you say draw a circle, you're taking away their opportunity to think about what they're actually trying to do there. So, yeah, I'll get them up sometimes. Say, "Okay, well, everybody stand 2 meters away from me," if it's possible to do that. Soon they start realizing that means a circle. So all equidistant from a point will give us a circle. So the classic way of perpendicular bisector is to do 2 arcs. But what I always start with 2 circles, so they don't get fussed about, or how long should the arc be? If I do 2 circles, there's no question there, is there? And then after a while, you can see, you say, well, you can cut this down actually. Make, this would be easier if we cut this down and use arcs. And then, the whole discussion about what the radius of the arc is, should I measure it? How long should that be? Now I've put measurements there, haven't I? And so you might say, well, hold on, we're supposed to be compass and ruler and pencil constructions, well, straight edge constructions. But to start off with, I do let them measure, and then I might give them another two. So I'll do another one after this, do another one on another page now. Okay, and I don't want you to do any measurements at all. So once we've done a few of those and they're happy with what they're doing, we label it perpendicular bisector, explain why it's perpendicular bisector, and this other language that I bring into is obviously that the perpendicular bisector are all the points, the rule is equidistant from point P and Q. Equidistant from point P and Q. So this would all be written up here as well. Because that word equidistant, to us it probably seems to make sense, equal distance, but for students, because it's a long word, I think they get a bit confused with that. So right now, you're all good at doing perpendicular bisectors. Here we want to do next. And again, so what they're aiming at here, we're aiming towards this circumcircle. And I think this is magical. I mean, it's a revelation to them that these 3 perpendicular bisectors will intersect at the centre of the circle that goes through A, B, and C. Now, this can take up to a whole lesson, and maybe even more, actually, depending on proficiency of the class. There's all the usual problems of using a compass. I do suggest you have your own little screwdriver to tighten up those compasses, and you may need to even give a bit of a little teaching session, just how to draw circles. Don't assume that they will know what to do, and a lot of them struggle with this. They're either very, very good at it or very, very poor at it to start off with, but they can all master it in the end. Okay, once they've done that then, and we've got the circle that goes round, touching at A, B, and C, this is the point we go back to the start of the lesson. So I say, okay, well, let's draw a triangle now, A, B, and C, join up those 3 points and repeat it. And what they'll end up with is in the circle that goes through points A, B, and C, and they can compare that to their own circle. And this is quite, it's quite nice. They're all quite proud, those ones, quite interested and proud if they've done well, to see how they've done and compared to others. So quite a nice way to see how well they can draw a circle. Quite a nice little activity there. Other directions I can go with this as well. I have bringing in modern references here. So which one is it? Fortnite. Okay, this was the most recent map when I last did this, but I'll make up my own questions about this, and print this out, give it to them, and they've got to find out. So a little bit hard to see what's going on here. risky reels in orange. I'll put orange dots on there to 3 points, but it starts to get them into the habit of doing, something a bit more exciting, something that's relevant, something they can relate to. Okay, and similarly, there's another map, treasure map here. I think you're probably on the front screen. You've got the same thing there. Equidistant from Smuggler Code and Hangman Forest. That use of that word again and again. Okay, scale is in there again. So probably teaching scale by the back door here, not having a lesson on scale. What does that actually mean? How are they going to make sense of that? And another thing that I've done, putting the bisector here, is with the school here. So I'll make up a scenario here. Okay, all pupils that live close to Sing Line, they do to Primrose Playing Fields, we're expected to walk to school. I don't think that's a bad idea. And we can get into a nice little friendly argument about whether that's a good thing for those students who actually live on the doorstep of the school but still manage to get there late. Show the area affected on the map. So they're going to have to think, what does that mean, closer to? So this is a little subtle difference, isn't it? A subtle adjustment to that perpendicular bisector question, because before they decide who lives closer, they need to find what is the boundary, where is the equidistant line between points that lie equidistant from Primrose Hill and Kings Langley. And you can do your own school map with this. It's quite easy, to get off Google Maps or whatever website you use for that. Okay, then angle bisector. Go through the process of drawing an angle bisector. And I like to give it the understanding with this as well. So once we've done this, again, depending on how much of a struggle we've had here, I don't want to overload here. But again, all the points are equidistant from lines A, B, and B, C. So, keeping that emphasis, and this is something that I'll come back to again and again over the times that we're doing loci. A perpendicular bisector equidistant from 2 points. Angle bisector equidistant from 2 lines. This is what we're doing at this stage anyway. Okay, so why does it work, the method? Okay, why does it work? I don't know if you ever thought of this yourself, but I get them to do a little square, draw a diagonal, measure the diagonals, measure the 2 angles. So what we can see here is confirming that the angle bisector is a diagonal of a square or a rhombus. So when we go to this one here, you will see from your construction, can I get this up here? Let's have a look. This is why I like, I've got a compass on this one. I don't have a compass on this one. Okay, the one at school I do, but this is the reason I do like this. So if you've done an arc there, your other arc's going to appear there and there. And so what you've actually got here is, if you've done it correctly, I mean, mine's not brilliant there, but you get a rhombus, and what you're actually constructing is the diagonal of a rhombus. So there's a reason for why it works. Again, there's no magic, it's just magical. And a similar task now we're going to do with the triangle, and what we do there is we find the angle bisectors of all the angles and draw a circle. So by the end of this whole section of lessons, they would have constructed a incircle, which is what this is, if it touches the insides of the triangle and the circumcircle of a triangle. Okay, now that in itself, sometimes say, oh, how does that apply to real life? There will be reasons, there will be, for design and graphics reasons, you get into that, but just for the fantastic reason that actually, who would have thought that would have worked? And obviously there's reasons why that works as well. You can take that further if you've got time. But for a lot of students, it's like you're doing these random constructions, and all of a sudden, wow, we've got this circumcircle or this incircle. Okay, so I think that's where I finish with. There's one more thing actually you can lead on to here, because I did say about construction problems, and I don't think I need to do a separate loci video on this, but I'm just going to show you something else that I've created, and this is how geeky I am sometimes. Okay, these badges were on cars. I print this sheet out, and students have to construct the badges. What we're doing here now. But I think you can do all of this by using circles, perpendicular bisectors, and angle bisectors. There is a bit of measurement involved, obviously, for the circles. Okay, there is a little bit of measurement, but it's possible to do this. So how are you going to get the 60-degree angle? Okay, and we get the 60-degree angle. We have to create three 30-degree, well, 60-degree angle actually. If we go back, I did have one, I don't know if you saw this before, construct an equilateral triangle. So that's a little stepping stone there, using a compass and a ruler. And then once they've got that, they can go on to these constructions here. And 11.25 if you double it, 22.5 if you double it, 45, double it, 90 degrees. So that's a successive angle bisector. Some of these are more difficult than others, but I've had some brilliant results from this. Just a little warning, this is probably for the more able, but you can probably get away with the BMW. That's probably the easiest one of those. Have a go, make your own up, let me know what you've got. Okay, so there will be a follow-on video for this for loci. I hope there's something in there that you can use or you can create yourself. I mean, I'd love to hear about what you create from actually looking at this. That would be inspiring to me, because then I can add to what I've got. We really are truly sharing there. And it might be better. I hope it is better, because I was always excited to use new resources. So let me know. Okay, and I will see you next time.